Hello, everybody. This is Matt Menifee, and this is my Week 5 progress report. So let's go ahead and jump in. So the focus for this week was fine-tuning the model that I created in Week 4 and graphing the results at each stage of completion. And then just starting the glove process, bringing glove into into Kaggle and using the pre-trained weights to run the model with and see if there's any improvements with that model after the weights have been applied. So this is the first iteration of the model. Again, this had 1D convolutional layers, 1D max pooling layers, and batch normalization layers in a sequential model. This had originally had nodes of 32 for the first convolutional layers, and then the next set of layers was 64. And this did not perform very well. It performed very poorly. Actually, it had an accuracy of 51%, which we can see down here. We can see the training accuracy increasing and the validation accuracy remaining flat. So this particular model really didn't do all that well. In the next iteration of the model, I did remove the max pooling layers, and I kept the batch normalization layers. This model also did not do much better at all. This also had just a 52% accuracy rating and did not improve from removing the max pooling layers. So this I thought was kind of interesting. I did play around with it a little bit more and did see some changes with changing the node size from I did change it from 32 to 128 for the first 3 convolutional layers, and I left the next convolutional layers at 64. And this did actually see an increase here, but what I thought was most interesting was in the final iteration of the model, I removed most of the batch normalization and simplified the model even further, which actually had the highest accuracy rating. So I removed the batch normalization after each convolutional layer and just kept the batch normalization before the flattening layer and then the dense layers at the end. I saw a 99% accuracy rating with this particular configuration with these convolutional neural network layers. So this was really a major jump from the previous iterations of the models that were only achieving a 51% accuracy. This, I'm not sure how much more I could actually really improve on this particular model for this analysis because it's already so incredibly accurate. The next step, though, I will still attempt to add the glove pre-trained networks to this model and just, the pre-trained weights to this model. And what these are is just a large weights from neural networks that have already been trained on previous data sets. Glove actually uses a co-occurrence matrix that's based on how many times words have occurred with each other. I mean, we can see a little bit of the geometry that I have taken from the GitHub website for Glove, which shows the comparisons of man and woman with the words associated with king and queen. That shows the vectors between these particular words. There's the city and zip code here that shows the co-occurrence of zip codes with these particular cities. So it's really interesting. It's a great transfer learning method. And if if there is any improvement on the model, that'll actually be pretty negligible at this point with a 99% accuracy rating with the previous iteration. But it will be interesting to see how well it performs in relation to the previous model. So the first step here is just bringing or downloading the weights into Kaggle, and then applying those weights to the model. So I'll be just using those weights with that neural network, and we'll see how much better it does in next week's review. Thank you very much, everyone, and I hope everyone's project is going really well. And I am excited to see how everybody else is doing. Thanks so much, and have a great week.